Thank you very much, Dabashis. It's great to be here again. I just arrived this morning. India is my homeland, but it's my first time I've actually set foot on this country, so it's quite an important event for me. And I want to thank again all the organizers for all the efforts here. I'm going to speak a bit on some of the basics. I'm going to touch on capsulorhexis challenge and then get into just sort of classic phaco techniques for all cataracts. And these are my disclosures, and I do consult for a variety of different phaco companies as well. Let's just briefly remember there are two ways to tear a capsule. One is by shearing, which is what you typically see, and the other is by stretching. Shearing is more controlled. Stretching is not as controlled, but can allow one to divert a capsulorhexis very acutely if one has to, if it runs out. These schematics just show a normal capsulorhexis. The shearing technique is the capsule folded over. You can see that the capsule is running out. If this occurs, of course, one has to look at the basics, look at the chamber shallowing, be careful on the incision to prevent viscoelastic from burping out of the incision. But the first thing to do is put the flap back, fold it back so it's unfolded again here now, and then grab the capsulorhexis about a couple of millimeters, 1 to 2 millimeters away from the apex, and pull 90 degrees to the direction where you wish it to go. So you want the direction to go this way, you pull this way. You see the vectors here again. So remember, not just pulling the center, you got to pull 90 degrees to where it wants to go. So here you can see we pulled the capsule 90 degrees to the direction it wishes to go. And you can see the capsulorhexis now starts to come back in again. So we've gone from a shearing technique to a stretching technique. We stretch the capsule to break the intermolecular bonds of the capsule, to bring it into the central portion, and then go back to shearing to allow it to continue. This video will just show the capsulorhexis starts off fairly well. You can see the capsulorhexis is going well. The surgeons folded the capsule over, allowing it to tear in a nice curvilinear fashion. But as we get nasally, it starts to tear out a bit more than we want it to. Immediately, one can assess the chamber depth, inject more viscoelastic, but really, if you're at this point in time, simply fold the capsule back, grab it again about a millimeter from the apex, not at the apex, at a millimeter from the apex, pull 90 degrees to the direction you wish it to go, and it'll come back in. And Brian Little published a nice paper with Mark Packer a few years ago in JCRS describing this technique. Remember to stop stretching when you have the rhexis saved and go back to shearing again and continue the capsulorhexis to join it back to where it initiated. So again, another example of a more intumescent cataract. The rhexis is going fairly well. These capsules can run out. You can see when the capsulorhexis approaches the subincisional area, you'll see it there, right there, starts to run out. You have to identify it, change the vectors, but if you can't change the vectors, then put the capsulorhexis back down, fold it back. Doesn't look good there, but you know what? Immediately grab it, pull 90 degrees, and there you go, you saved it. Okay? It's a very quick move, and if we stop there and inject more viscoelastic, the capsulorhexis may have come out. So that's the concern. What about chopping? I pretty well chop most lenses. Horizontal chop typically means the chopper goes out to the periphery, typically to the endonuclear border. The phaco is then buried into the nuclear substance, and then the chopper meets the phaco tip. Well, vertical chop is more of a vertical motion or quick chop, where the chopper is placed closer to the phaco tip after the phaco tip has been embedded and chops the lens in half. There are different choppers that are available. This is the vertical chopper I like the curve on this. It's a beveled tip. It's sharp enough to do vertical chopping, but can be used for horizontal chopping as well. It's got a beveled inner side as well. There are other ones that are specifically designed, as you see here, with a larger surface area to crack lenses. And the classic horizontal chopper has a safety bulbous end on it to avoid potential capsular trauma. I typically still use a vertical chopper, as you'll see here. You'll see the hydrodissections done in the soft lens, as well as hydrodelineation. Soft lenses are generally harder to crack and chop than dense lenses, but a horizontal chop can be very effective to slice the lens in half. Here's the hydrodelineation. For me, it's essential to know both hydrodesteps for these lenses, not only hydrodissection, but other delineation as well using a special chain cannula. Notice the vertical chopper reaches the endonuclear border. We hook it down. The phaco tip starts proximal, ends up at the center, and the chopper meets and goes past the phaco tip to allow the slice to occur. This is like slicing bread. Here we do a hemi-flip where the hemi section is flipped up. It's a very quick motion. You'll see it in next videos. We've done one hemisection. Now the chopper is used to manipulate the other hemisection. Because of the good hydrodelineation that's been done, it's easy to remove the endonucleus. Now the epinucleus is flipped using typically just aspiration, and linear vacuum. I like using linear control of phaco and vacuum and flow, not just phaco power. Some people like panel set where they have fixed vacuum and fixed flow. This is the big advantage in using linear. This somewhat more moderate lens, we're going to do a vertical chop, bury the phaco tip, go to the periphery, and then bring the chopper to the phaco tip. See that? Did you see that quick motion? That was the quick hemi flip. By the way, the softer the lens, the farther the chopper should go away from the tip. The harder the lens, the closer the phaco tip and the chopper can be during the initial crack. Look at the quick hemi flip. Look, quick. The chopper brings the pole forward, and now we flip the hemisection to the mid-iris plane. Here's the second hemisection. It's flipped up. So the hemi-flip technique I published many years ago, for me, is my go-to technique for soft to moderate lenses. One chop in half after hydrodelineation, flip both hemisections, and then very rapidly and efficiently phaco both hemisections, and then aspirate and flip the epinucleus. This lens is a little bit more dense. We're now getting into a bit more 3+ perhaps. We're going to bury the tip, make sure you're using enough phaco power, and then the chopper is brought just mid-periphery to the center, vertical motion and then horizontal motion. Look at the back crack. We're cracking the lens both centrally and peripherally. Here's a cross chop. We're going across the chopper, across the phaco tip, doing a cross chop. We have one small quadrant we can remove. This is all done without rotation, which is an advantage of cross chopping. There we're going to emulsify the lens in the iris plane. We have 1/4 left on the right hemisection. We're going to phaco that one as well. And remember, the chopper actually does more work manipulating the lens fragment than actually chopping. If you see how active the chopper is, the idea is that the nuclear fragments are brought to the phaco tip rather than the phaco tip chasing the nuclear fragments to the periphery where it's more dangerous. Rotating the lens, and again, now we have room to bring the lens to the center, and then again, using a hybrid. So even though we have horizontal and vertical chopping, most chopping you see here is a hybrid of both vertical and horizontal together, not necessarily pure horizontal. The first case I showed was pure horizontal, where we're going to hook the endonuclear border first. This lens is a bit more dense. Bury the phaco tip into the lens substance. Notice that we're burying the tip. We're starting subincisional. Don't start in the center, otherwise you're going to end up in the periphery. Start in the periphery so we end in the center. The key point with phaco is getting a nice crack down the middle and crack in the lens. Without a central crack, it becomes more dangerous to do the phaco because of the potentially posterior bridging fibers, making it difficult to extract small fragments like we're doing now. You see a small rotation helped us to do the second chop. We're then basically multiplying this phaco, this nuclear tip very rapidly. I sometimes find surgeons chop the lens into 8 different small fragments. I find it unnecessary with the advanced phaco technologies we have now. Once you get easily enough small fragments and small quarters at least to bring the quarter into the iris plane, you're good enough to phaco. Here we see now we're going to rotate the lens, bimanual rotation here, turn the phaco tip so it faces the face of the heminuclear face, and then again we have a nice chop that was basically again a hybrid vertical horizontal chop. Rotate the lens and carousel the lens necessary to do this. Sometimes we have small pupils here. We'll talk about small pupils in other sessions here. I really like to do small pupil phaco as long as the rhexis is big enough. Here I'm making a rhexis beyond the pupil margin with the assistance of a Kuglen hook. And yes, those of you who are asking, certainly I can use a Malligan ring or iris hooks, but I find viscomydriasis and the assistance of a second instrument is good enough to do a good-sized rhexis. This is where hydrodissection is done. This is where chopping is very helpful in small pupils because we don't have to go into the periphery. We stay in the center. The chopper goes to the mid-periphery, vertical, horizontal, hybrid chop occurring here, and then we go again back to our chopping or cracking approaches here. Hemi-flip the lens so the hemisection is brought forward. Again, the key point to do this is something we often forget, which is a very good hydrodissection plus or minus hydrodelineation. We do hydrodelineation when the lens is soft to moderate, but we don't do hydrodelineation if the lens is dense because there's really not much cortex or epinucleus to really separate. Here again is the hemi flip again. We basically turn the phaco tip so we're facing the edge of the hemi section, bring it forward, and again, actually in this case, we're actually going to then turn it on its side to do a hemi flip technique to very rapidly phaco the tip. Now in this case, you probably saw we basically went from longitudinal to torsional, which I should have mentioned earlier. When we're doing phaco, chop, we like longitudinal only, so we can bury and lollipop the lens. But when we're doing fragment removal, we go to torsional, because torsional is better at carouseling the piece. Not so good at lollipopping nucleus, but better at carouseling pieces. This is a very dense black lens. Here, chopping alone will unlikely chop the lens in half full thickness. Here I do a partial groove. That's why it's still important to know how to groove. We groove down the center. We start subincisionally and end up in the center. Once we get deep thickness here, we have a small fibers left along the posterior capsule. We'll then bury the phaco tip in the nasal part of the lens and basically crack it in half. Once we crack it in half, we make sure we have a full thickness crack. We'll continue to chop each small little hemi section. Here we're going to chop multiple small quadrants. And these are all ways that we can, again, use chopping techniques to handle these dense lenses. And again, making sure we have good viscoelastic in the AC to protect the endothelium. I have more videos online. Feel free to visit online. And again, those are some technique pearls for capsulorhexis, saves, as well as phaco chopping all densities of lenses. Thank you again, demonstrators, for the kind invitation to this meeting and to this instruction course as well. Thank you very much.